Hello and welcome to my session on It's All About the Data. My name's David Eagle and I'm the FME Division Manager at 1Spatial. I focus on our partnership with a company called Safe Software based on the west coast of Canada in Vancouver. Safe make a product called FME that no doubt many of you have heard of already. And the FME division at 1Spatial is made up of a team of specialist consultants, and we spend our time helping our customers connect to their data, transform it and create automated workflows to save them time and effort. Now, I have a two-part agenda for you today because I wanted to offer a little food for thought in the first part around the theme of the day of insight and analytics, and hopefully that will prompt some discussion later in the panel sessions. And then secondly, I was asked if we could share with you some of the data challenges, analytics and outcomes that we've witnessed some of our clients doing with their data during this rather unusual time that we find ourselves seemingly trapped in, for the medium term at least. So that's the plan, and I hope you find it interesting. Now, I appreciate that this is an extremely overused quotation, but when it was recorded by The Economist in 2017, it served to draw attention to all of us, actually. And I guess there's nothing wrong with promoting our craft on the coattails of a little marketing. You might not subscribe to this sort of rhetoric, but it's certainly hard to deny that there's rather a lot of data available to us these days. And you don't have to look too far to find it. The data that's been coming out of the various DEFRA departments over the last few years is staggering, even if the only metric you base that statement on is the file size of some of the LiDAR data available. Equally, you can look at the volume of content available from AGI GeoCymru, who, befitting our theme today, are putting data and intelligence at the heart of public service delivery. Or why not browse Stats Wales, as there you can extract definitive data that's filterable and in many cases available at the end of a REST endpoint. And given the current climate, you shouldn't forget Health in Wales, which is an outcome commissioned by the NHS Wales Informatics Service and of the Welsh Assembly Government to enable people in Wales to become more involved in their health. One way to do that is to provide reliable information about essential health matters. And there's the nub, one word, reliable. So perhaps we'll move to a less well-trodden path for our next quotation before we deal with that issue of reliability. I attended an event a fortnight ago that was focused on the architecture, engineering and construction sector, and the focus was managing the wider supply chain for projects like High Speed 2, the rail line that's going to help Londoners spend an extra 20 minutes in Birmingham. Anyway, Clive Pulse made this statement, focus on the data. And it might seem completely obvious and worthy of no further comment, but it was the context that hit home to me. Projects as significant as HS2 have rather a long timeline. Phase 1 to Birmingham is likely to be completed in 11 years if we're lucky. Phase 2, getting us up to Leeds and Manchester, might not be completed in time for me to go to my retirement party at the Manchester Arena. The point he was making was that the applications, the tooling, the systems, the databases, and in many cases the people aren't likely to be around in 5 years, let alone 25 years. So if you don't think about how you capture your data and what you capture, you're giving yourself a fundamental challenge. You're going to need to use it and gather insight from it pretty soon, but you're also likely to have to move it at some point when you change your supplier, or swap out your GIS, or change your document management system, or move your database from proprietary to open source. So the message was loud and clear. Think very carefully about your data. And now back to that reliability. We've all had this conversation and it crops up in some form on every project you get involved with. But it's not your fault and it's not theirs really. We have to be in it together because we're always driving the agendas from the conclusion. And what I mean by that is we often know the question we want answering now, but we didn't know the question when we captured the data, so the data's always going to be slightly wide of the mark. So all we can do is our best and focus on the data and the quality of the data. This is an example we see commonly with coordinates mistakenly transposed by someone who got their longitude mixed up with their latitudes, or maybe when they scaled their CAD data from 00 to British National Grid and converted to a shapefile, what they actually did was offset it and didn't notice that they also completely broke the precision. I'll give you an isolated example of what I mean by data quality and reliability, and it's one we have to tackle on almost every project we work on, and put plainly, it's nothing. A few years ago, Safe Software did some research and they looked across all the data formats that FME supports. And as of today, FME includes support for around 500 data formats. Safe looked at that list of 500 formats and they identified that they actually support around 20 types of nothing. It sounds bonkers, but databases, for example, have a concept of null. A null attribute is the equivalent of storing nothing as something, and it crops up a lot in data migrations because database administrators like to add constraints to their tables to exclude the loading of nothing. You quickly figure out you've got a problem when you try to upload a CSV to Oracle with 10,000 rows and you only manage to load 50 records. You've just found the lesser spotted nothing in the wild. But null comes in many forms. Formats like mapinfo tab don't support null, but instead in an integer data type they store nothing as something, a value of -9999. Some formats like CSV allow you to store empty strings. You'll be familiar with that when you open a CSV and find two commas next to one another. Formats like shapefiles allow you to store a value of 0, but that's confusing because that could actually mean you don't have any tree preservation orders in that park, rather than you don't have data on TPOs for that park. A very different meaning of nothing. And this is just tabular and vector data. Raster data, to complicate matters, has a concept of no data assigned to certain cells, and that could mean the pixel has no color, or it could mean that in a numeric raster you've got no rainfall for that cell. So if there's this level of ambiguity in just one aspect of a data set, we have to take care with quality and content of the data, but also the format that we choose to store our data in, so that it stores it with the precision and reliability that we need, and we avoid any ambiguity. I'll never forget a personal example of this when I was involved in collecting origin and destination travel survey data for a transport study for a road improvement scheme. We were asked to question drivers and ask them for just the first part of the postcode that they were coming from and going to. The reason behind it turned out that people seemed more willing to give you their postcode if they only had to give you half of it. They felt it wasn't such a privacy intrusion. Turned out that after what was a very expensive data collection exercise involving the local police to flag down drivers, when the data was collated and analysed, it wasn't able to inform the road improvement project because the area was rural and the postcode districts represented by the first half of the postcode were geographically enormous, and you couldn't pin down which route people were actually taking through the problem area. It was a classic example of not working out the question you wanted to ask of the data before you went to get it. So there's a beginning, a middle and an end, and data has a life cycle, and the point I wanted to emphasize is it's wise to think through the life cycle as a collective as much as you're able to do, rather than each phase in isolation, or worse still, work in silos in an organization. Data is about collaboration. I'm old enough to remember the original principles of the DNF, the Digital National Framework, the precursor to the development of Ordnance Survey Master Map. The concept was outlined at an AGI conference just like this, back in the heady days of 1999, when we all used Netscape and Alta Vista to find out an answer online. The principle of the DNF was capture once, use many times, and all I'm suggesting is that if you want to repurpose your data and make it reliable and allow it to transition easily between different systems, it's worth putting in a little groundwork to make sure that the insight you want to glean from the data is actually going to catapult you towards making a decision, rather than being a millstone round your neck of constant data maintenance with little value returned. Since most organizations aren't capturing data from scratch and generally already have rather a lot, the tasks we get called in to help with are data moves, when there's a system change and data needs to be migrated to a new environment or container. Data validation tasks when a data set's quality has been called into question, and instead of manually fixing it, we deploy our rules-based technology to identify the problems and automate the fix-up. And we also help organizations deploy their systems. But before we do any of that, we want to have an understanding of the data, and more importantly, we want to know what outcomes it's going to drive, because that feeds the data journey. We've found that applying agile working principles suits this process really well, because we work with key stakeholders in your organization to understand your data and link it to the underlying business needs. We combine data review techniques, specialist tools and sprints to assess data quality, improve understanding and model the desired outcomes, and it generally all starts with a workshop where we gather together all the stakeholders to unpick the why. A good friend of mine, rather annoyingly, frequently reminds me that a good DIYer does 80% preparation and 20% job. Now, from that comment, I'll let you decide if you think I'm any good at DIY, but this analogy is so relevant to data quality projects, a data migration project, a schema mapping requirement, a simple data translation. Prepare your dust sheets, paint the wall, clean your brushes carefully, and for God's sake, don't kick the paint tin over. Now, I trailed this session by saying I'd conclude with a brief overview of how our customers have been using FME to tackle their own unique data challenges in relation to the pandemic. And I'm not going into detail about what FME is today, so if you're not already aware, then that's one for you to follow up with me separately if you're interested. What is important though is that up until recently, if you're already an FME user, we've made free licenses available to home workers who couldn't reach the FME licenses installed in the office, and whilst we've all dealt with the hiatus of shifting our desks into the front room, and we're continuing to support research and COVID-19 related projects at the moment too, with licenses until well into the new year. And we've been helping do that since all this started, so here's a few examples. At the start of the year, for example, it was necessary for all schools to complete attendance records. The primary reason for this was safeguarding, to ensure no children dropped off the school's radar. The Department for Education supplied a spreadsheet template. Of course they did. Public Health England have shown us in the last week that this never ends well. Anyway, what was meant for Stockton was they needed to complete one spreadsheet for each school, of which there are 70 in Stockton, and they needed to do that every day. It was a huge workload in itself, but for their own purposes, they wanted to take that captured data and the effort and repurpose it for when their needs for their own needs by conflating all 70 spreadsheets each day and squirting the data into Power BI, so they could track the local trends to be able to predict resourcing levels and anomalies. The actual challenge was a bread and butter task for FME, and since Stockton had a support contract, we solved the challenge for them via a support ticket. The conflated data was output in a structured way, and they could easily plug it into Power BI. With GeoCymru, and many of you will know Tom Timms well because he's a big supporter of this event, GeoCymru have a data product called UK Map, and they created a really neat bit of value add for some of their customers who wanted to be able to identify pavement pinch points in their local authority areas to inform them around the challenges with social distancing. Tom's team took their data and used FME to derive pavement widths for the Greater London Authority region using a geometric calculation based on deriving a centre line down each pavement, producing perpendicular lines to it and then calculating the overall average width per pavement segment. The result is that they're able to theme pavements now to highlight areas where social distancing would be a challenge. This can then inform street closures and pavement widening schemes, as we've seen in many parts of the country. Barnsley Metropolitan Borough Council are an example of an authority that have gone all in, specifically focusing their attention on the identification of vulnerable individuals in their region who might need extra services. They very quickly spun up a dedicated SQL Server database and set up 2 dedicated FME server engines to constantly feed updated data from all their partners into the system, from which they could gather insight into at-risk persons in the community. The dataset list here are just a handful of the datasets that they have set up automated routines to gather, filter and store, and again then surfacing the results in Power BI. And finally, I wanted to finish with Luke Cooper. Luke works for Arup in Cardiff and his wife works as a nurse, so he wanted to be forewarned of the upturn of COVID-19 cases so he could help his family. But he also he's also a data scientist and a hacker, and I use that term with the greatest of respect. So with minimal tooling, he wanted to see what he could achieve. Luke used an FME process hosted on FME Cloud to automatically scrape data from Public Health Wales and the COVID symptom study from NHS Wales on a schedule, and he fed the data into Esri's ArcGIS operations dashboard because he found that it was fast and because it was easily supported on mobile devices. And this is what it looks like with cumulative charting and time series data, new case stats, testing by region, cases by region, as well as age and gender splits. And if you want to see the detail behind this specific example, you can watch the full presentation of Luke's data analysis journey by going to our on-demand webinar page, and the shortened URL there will also take you to the dashboard itself. And there we have it. Thank you very much for listening, and I hope you enjoy the rest of the event.